1.6, solving linear inequalities in one variable. Your essential question, how do you solve and graph simple and compound inequalities? And to kind of, this is a nice review, so to just kind of review it, I think I'm going to make a table where we'll list what the symbol looks like, what it means, what it looks like maybe on a graph, and then an example of that. That should work. So actually, before I do that, I don't know how much room I'm going to take up, so I'm just going to go ahead and put little column headings with lines under them. All right, so first one is the greater than symbol. Okay, so that whatever number was here would be greater than that number. The meaning of that is greater than. I'm going to go ahead and use 2 lines for that. The graph of this, well, you're gonna have an open dot, so I think that's what I mean by graph, whether it's an open or a closed dot. For example, x is greater than 3. So basically when you graph this, let's just put 0 here, put 3 there. I'd have an open dot because it doesn't actually equal 3, so I'd have an open circle at 3, and then I can graph everything to the right, which basically means that the solution, all the solutions are all numbers larger than 3. So 4 is a solution, 4.5, 4.67, 10 million is a solution. All right, so that's one. So now maybe I'll do little lines in between. Okay, well then you've also got greater than or equal to. So this is greater than or equal to. This one's going to have a closed dot or closed circle. So if I have x greater than or equal to 3, then on my number line, I'd have a closed circle, and it's going to shade all numbers larger than or equal to 3. And then we'll do the same thing for the less than symbols. So this is less than. Once again, this will be an open dot. So if I did x, how about we just stay with 3? X less than 3. Then the graph of that. Open dot at 3, because it can't equal 3, but it can be all numbers that are less than that. So you shade in that left side. All numbers, so 2.99 can be a solution, but so can negative 5 million. And then the last one there is less than or equal to. This one's going to be a closed dot. And so if we had x less than or equal to 3, close up that circle and shade all values that are less than or equal to 3. Okay, pretty nice review there. So what we're going to do is we're just going to work with inequalities. We call them linear inequalities. They're just on like a number line. So we're not going into 2 variables yet. We're just working with one variable like x. So you won't have like an x and a y. You're just going to have one variable. And we're going to solve them and we're going to graph them. And you basically solve these. So you solve inequalities just like you solve equations. I'm going to write a little note here. So solve inequalities just like equations. Except, there's a big except there. There's one exception. When you're solving these things, if you have to multiply or divide both sides by a negative, you need to flip the inequality sign. So if you, except, when you multiply or divide by a negative, you must flip the inequality. That's huge. That's the only exception though. Otherwise, these are just like solving regular equations. So let's do a couple of these. So example 1. Let's solve. How about we'll do 11y minus 9 is greater than 13. So just imagine that that's an equal sign. The only difference is, like, if I ever divide or multiply by a negative, I'm going to have to flip it. Okay? So right now I'm focused on y. I'm just going to add 9 to both sides. Let's get y by itself. So I got 11y is greater than 22. Divide both sides by 11. So y is greater than 2. Let's graph these two. So I know it just says solve, but I'm going to put solve and graph. That way we get practice with that. Okay, so y is greater than 2. So I just put 2 somewhere, in relation to 0. That is an open circle or an open dot because it can't actually equal 2. And I shade all values that are greater than 2. Hopefully you're finding that pretty simple. Okay, let's do another one. Example 2. Okay, we're going to solve and graph. So let's go with 7x plus 9 is greater than or equal to 10x minus 12. So I'm going to get my x's on one side and everything else on the other side. So how about, just to make this fun, I'll subtract the 10x from both sides. And I'll also subtract the 9. So I'm bringing all the x's to the left and everything else is going over to the right. So this is a negative 3x greater than or equal to negative 21. So to get x by itself, I divide by negative 3. That's important. If I'm dividing by negative, this sign is going to flip, right? Because basically everything's changing values. What used to be negative is now going to be positive. So this is now going to be just x less than or equal to 7. And so then to graph that, I'll just put 7 there. That is a solid circle or solid dot. And I want all values that are less than, right? This is the less than symbol. I kind of think of this like the alligator eats the bigger number. So that's one way you can think of it. So x is the smaller number because it's not being eaten, right, by the alligator. 7's the biggest number. So 7's the biggest we can have, and then we shade all the numbers that are left of that. All right. Compound inequalities. So let's talk about compound inequalities. So compound inequalities are it's two simple inequalities joined by and or. Okay. So two simple are just these types of inequalities where we just got one variable. We're not like graphing these in the coordinate plane with like x's and y's. It's just on a number line. It's pretty simple. Two simple inequalities joined by and or. And here's a couple of examples. Okay, so the one that is joined by and is always going to have your variable like in the middle. For example, x is greater than or equal to -2, and at the same time it's less than 1. So basically, when I graph this, I'm really just shading the areas between -2 and 1. So if here's 0, here's -2, here's 1. Well, at 1, I have an open dot because it can't equal that. But at -2, it does equal, x is equal to -2 as well. So it's a solid dot, and it's all the area in between that. So that's your and compound inequality. There's also the or compound inequality. Now this one turns into two separate inequalities. So it's x is less than -1 or x is greater than or equal to 2. So this one, you're going to end up with like two separate graphs on the same number line. So I'll have -1, 0. Oops, that does not look like a 0. I'll put 0 right here. And then 2 out here. So x is less than -1. So I've got an open circle there, shading everything that's less than -1. Or x is greater than or equal to 2. So that's a closed circle, and I shade everything that's bigger. So there's the difference. Your and, it's written as like one long inequality. The graph is going to be shaded between 2 points. The or, two separate inequalities, and actually like two separate graphs on the same number line. And this is just supposed to be a dot, nothing more than that. Okay. So let's solve some of these. Let me get another sheet of paper here. So we will solve and graph these. I'm going to call this example 4 because I'm just kind of going by what your book is doing as well. So that way you can go back and you can look at problems with your book. Trying to find some ones that are a little bit different than your book, but they coincide with the examples in your textbook. So this is solve and graph. All right, so how about we do this one? Let's do -12 is less than 3x minus 3, less than or equal to 15. So this is an and problem. Okay, so this is an and. I'm going to write that down. Notice I've got one compound inequality. When I graph this, I should have like a section on my graph that's just shaded in between two values. Okay, similar to this. Now you can solve these in a couple of different ways. One way is to just go for it. So I'll do that, and then I'll show you the other way, okay? So one way is to just say, I'm just going to, everything I do to solve for x, I got to do to every part of these inequalities. So I got to do it on all sides. So there's a left, a middle, and a right. So if I decide that to get x by itself, I need to add 3, then I need to add 3 on all sides. So I'll have -9 less than 3x less than or equal to 18. I got to get x by itself, so I'm going to divide now all sides by 3. So I get -3. Now notice I didn't divide by a negative, so I'm not flipping anything. Just because this ends up being negative doesn't mean that I'm flipping anything. Only if you had divided or multiplied by a negative. Okay, so when I graph this, I've got -3. I got +6 on the other extreme. Let's just put 0 somewhere in the middle. just so I know that that's where it is. All right, and x is greater than -3, so I'm going to have an open circle there. It's greater than, so I'm going to shade this way. But it's less than or equal to +6, so that's going to be a closed circle, and I'm going to shade that way. So I'm basically shading everywhere in between. And those are all my possible solutions. Another way that you could do this is you could set it up so there's one inequality, and there's another inequality. And when you solve this inequality, you would get x greater than -3. And when you solve this inequality, you would get the other part of this, x less than or equal to 6. And then you would just graph both of those and put them together, okay? Because it's an and that's what an and compound inequality looks like. It's inclusive. It's between two values. There's a whole bunch of solutions. All right, so let's do another one. And so this might be important. You might want to highlight that. Example 5. Again, solve and graph. And we'll do, how about -2x plus 7 less than 3, or 3x plus 5 less than 2. So for these, you've been given two separate inequalities, solve them separately. So you're going to subtract 7 from both sides here. We've got -2x less than -4. Divide both sides by the -2. Notice I'm dividing by a negative, which means I'm going to have to flip that symbol. So this is actually x is greater than 2. Or let's solve the other one now. Subtract 5. I get 3x is less than -3. Divide both sides by 3. X is less than -1. Okay. Now you're going to have two separate branches because this is an or example. Here, I'll write that over here in big letters. Or. Okay, you got an and up here, you got an or over here. So the or example is where you have two separate sections on your number line. They're usually going to go in the opposite direction, so they're not going to overlap. And has overlapping or not overlapping. So on a number line, let's see, -1's over here. Let's put 0 somewhere, and then how about 2's over here? So x is less than -1. I got an open circle, and I want all values less than -1, so I'll shade going in the left direction. And x is also, or I should say, or x is greater than 2. So again, open circle because it's not equal to, and I'm going to shade to the right for all larger values.